Good day everyone. Welcome for today's tutorial. Today we are going to look at something very vital on calculus and how to solve the questions step by step. So I want you to pay attention as we dive into the topic before us today, differentiation in calculus. Thank you very much. Now let's look at number one. Say differentiate y equals to 5x cubed plus 3x squared minus 1. Now for us to be able to differentiate this function, you need to understand that solution, when differentiating, in differentiation you have the rule that you use when differentiating a function, and this is if you have, for example, if y is equals to ax to the power of n, if y is equals to a to the power of n, you also be able to find dy by the x, because dy by the x also means what? Differentiate or differentiation. So for us to find the derivative, which is dy over the x, which means the same thing as what? Differentiate or differentiation. This is the meaning. Then for us to find the derivative of dy over the x from this function, we are going to have this power, this is the power here, the power n here, we multiply, we come down here and multiply the entire function. Multiply by what? The entire function is what? Ax n. I hope you understand. We are using this power now, we are bringing down this power to multiply the entire function here. Then we subtract 1 from the power. This is the method we use when differentiating a function. So just pay attention to this so that when we are trying to apply the rest of this question, you can know how to solve it correctly. So now let's know how to solve this guy. Know that the equals to what? We say that y equals to what? Y equals to what? Equals to what? 5 x cubed, right? X cubed plus 3x squared minus 1. Now for us to find the derivative, which is dy over the x, we use this method, the power rule method, which is our dy. Now solution, our dy means what? We are deriving the function y with respect to what? X. The x is what? With respect to x. Y now is the function we have. And the x means that the parameter in the function is what? With respect to what? X. For example, if this was t, this would be what? dt, and if this was like v, this would be what? dt all over dv. Because v is the parameter in the function. But at this particular case here, what we have is what? Y as a function, and x is the parameter in the function. So that's why we use what? Dy over the x. So we are deriving the function y with respect to what? X, because x is the parameter in the function. So let's derive it. Now, for us to derive this guy, you know that this is the power, right? The power 3 now, we come down. So now look at 3, right? We bring this 3 here down. Then multiply the entire function we have here now, which is what? 5x what? 3, right? I hope you understand. Now at this point in time, what we are going to do now is to subtract 1 from this power 3 minus what? 1. So we are going with this first term. Now we come to here, you have a cross, right? Now here you have 3x squared, right? This is power 2, right? This power 2 will come down, we bring down power 2 here. Then we multiply it by the entire function, which is what? 3x squared. 3x what? Square, right? I hope you understand. Then the next thing we do is to subtract 1 from the power. So we minus 1 from this power, right? Now this is constant. When we are differentiating a constant, it's 0 because it does not have a value that attached to it. So that's why we are having what? 0. And for us to differentiate this guy, let me assume that, see we are differentiating with respect to x, right? Let me assume that this is minus what? X 1 minus x is the power of 0. I hope you understand. now going to derive this guy. I don't attach with respect to what x raised to the power of 0 because all of indices, anything raised to the power of 0 is what? Is 1. So this x is 1, right? Now 1 times 1 is the same thing as 1, right? So let me look at how to differentiate this term. How we got it as 0. How we got the constant as 0. That's what I want to derive it here. Now we know that we still have what? The y over the x, right? Equals to what? What we have is what? 3 times what? 5x what? 3, right? Minus 1. Then we have plus 2 times 3 x squared minus 1, right? Times now. I just insert this guy x to the power of 0. So I want to prove how we got as 0, right? So you know that for this case now, the power which is 0 will multiply the entire function. So I know that here there is minus, this is the minus. That's how to put this minus. Then this 0 now will come down. Since this is the power, right? Then we multiply by 1 x, right? Now 1 times x is the same thing as 1, right? And the same thing as x. So this is multiplied by x, right? Now you know that this x now is the power of 0, right? We subtract 1 from the power. I hope you are following. Now at this point in time, you have already divided all the terms in this place. Let's look at the final answer. So our dy over the x is equal to what? This is 3 times 5 is what? 15, right? Now we have x, right? This x here. Now 3 minus 1 is what? Is 2. So we are done with this first thing. Then cross here, plus 2 times 3 is what? 6, right? That's 2. Then we have x here, right? X. Then 2 minus 1 is what? Is 1. And anything raised to the power of 1 is same as 1. That's why I have anything raised to the power of 1 is same as that thing. So this is raised to the power of 1 and it's the same thing as what? X. Because 1 raised to the power of x is the same thing as x, right? So we are done with this guy. Now, if you look at this guy now, you look at this guy, we have what? Minus 0, right? Times x raised to the power of 0 minus 1. If you multiply 0 to any term, it's the same thing as what? 0, right? That's why I have here minus 0. Now at this point in time, our divided by the x is equal to what? 15x squared plus 6x. And this is the final answer for this question. This is the final answer, 15x squared plus 6x. So just solve it by yourself and you see how we got the final answer here. Now let's look at it. We said we should differentiate the function y if y equals to what? Square root of x plus what? 3x minus 1. We said we should differentiate what? This guy. What they are asking us to find what? The y over the x. So then I have to solve this guy, I have to differentiate this guy. Solution. Know that what they give us for the function what? Y equals to what? Square root of what? X plus what? 3x what? Minus 1. Now for us to be able to differentiate this guy, know that at different point we can't differentiate because of this square root, right? So know that this square root is the same thing as what? The y is the same thing as what? Based on law of indices, this square is the same thing as what? X raised to the power of what? Half. Just try to convert this guy because half, this is the same thing as what? Square root of what? X. So we just try to change this square root as what? 1 all over 2. Because based on law of indices, they are the same thing. They are the same thing. Let's have converted it to here. Plus, what you have here is what? 3x minus 1. Now let's look at the dy over the x. Let's find the dy over the x. The dy over the x. Deriving the function y with respect to x parameter is going to give us what? Now based on power law that I gave us initially, you know that the power here will multiply the entire function. What is the power of x? The power of x here is what? Half. So we are going to bring half at the time here. Then this half now, which is the power, will multiply this entire function, which is what? X raised to the power of what? Half, right? Now, at this point in time, the next thing we are going to do is to minus first thing you are going to do when differentiating, you are going to use the power to multiply the entire function of that thing, which is this guy. Let's try to have this guy. Now, that is the first thing. Then the second thing now is subtract 1 from the power, as I did here. Now we are done with this one. Then plus, there is plus here. Then this is the power. This term now is just for power minus 1. So this minus 1 will come down. This minus 1, there is plus here, right? Now at this point in time, this minus 1 will come down. So we have minus 1, right? Minus 1 come down and multiply this entire function, which is what? 3x minus 1 that was here. This minus 1 is still there. It's still there. Just bring it down and see subtract 1 from the power 1, which is what? Minus 1. I hope you are following. Okay, that's good. Now at this point in time, what we are going to have here then is what? Our dy over the x is equal to what? Here we are having what? Half times x what? Is x, right? Now if you look at this guy, 1 all over 2 minus 1. Look at it. 1 all over 2 minus 1. Then you put in form of fraction. This is all divided by 1, right? The common term is what? The LCM is 2, right? 2 go here what? 1. 1 times 1 is what? 1. Then you put this minus. 1 going to 2 how many times? 2 times, right? 2 times 1 is what? Is 2. So we are going to have what? Minus 1 minus 2 is what? Minus 1. All over what? 2. So what we are going to have here is what? Minus 1 all over 2 as the power. This is 2. Then you come to this side. Plus times minus is what? Minus, right? Then 1 times 3x is what? Going to give us what? 3x. But we know that this x now is the power of minus 1, minus 1. Minus 1, minus 1 is going to give us what? Minus 2. So therefore, our dy over the x from here now, dy over the x, we have here what they have here. What's what? 1 over 2, right? This is what? X. This is power of what? Minus 1 over 2, right? Minus this what? Minus what? Minus 3x minus 2. Minus 2. Sometimes you can leave it at this form. You can leave it in this particular form. If you know how to expand it, but if you want to expand it, you can go ahead and say dy all over the x equals to what? Look at this guy. This, because there is minus here, this is going to give us what? 1. Because it's a form of fraction. All over what? This is 2. Then we're going to have what here? We're going to have, let me put it at this form. We're going to have x. This is power of 1 all over 2. I'm trying to just explain this step. 1 over 2. Because this is 1. This minus is representing this one. Is representing this one here. Let's try to put this one here. And we see no, we have 2 at the front of the x, let's try this one is here. Then minus what? This have what? 3. We have what? Now if you look at this guy, we have minus 2, which is the same thing as what? 1 all over what? X is power of 2, right? Now at this point in time, what we're going to have here now? Therefore, our dy over the x is equal to what? Look at this guy, we have 1 all over this guy, because it's 1 all over 2. It's the same thing as square root, so we have 2 square root of what? X. Because this guy is squaring this value x here. Because the x, 1 over 2 is related to what? This power of x. That's why it's squaring this guy. Then our final answer here becomes what? We're going to have minus what? 3 all over x squared, and this is the final answer for this question. So you don't know how to solve it step by step. Now let's look at the third question. The third question we have here, we say we should find question. We say find dy over the x. Find dy over the x if y equals to what? Now, at this point in time, if y equals to what? 2x squared minus x cubed plus what? 5. Also, differentiate it directly. Solution. You know that our y is what? Our y is what? Is given as 2x squared minus what? X cubed plus what? 5. Now, what to find divided by the x? Our dy over the x is equal to what? This 2. We bring down this 2, we have 2 here. This power 2, we bring it down, we have 2. Then we multiply that 2 with this entire thing, which is what? 2x squared, right? That is the second step. Then we minus 1 from that power 2. Yeah, minus 1 from the power. Then minus, there's minus here, right? This 3 here will come down. You have 3. This 3 will come down, we have 3. Then multiply it with this 10 here, which is what? X in power of 3. Then subtract 1 from the power. Subtract 1 from this power. Then plus, no, this is 5. Since this 5 plus 1 have x attached to it in this aspect, this becomes what? 0 because it's a constant. It does not have any variable. So this becomes what? 0. I've taught that already from our previous question. Therefore, our dy over the x equals to what? 2 times 2 is what? 4, right? We still have for x, right? I know that 2 minus 1 is what? 1. I need to use the power of 1, same thing, and that's 10. That's why I have 4x. There's an invisible 1 here, so no need to put the 1. Then minus 3 times x is what? 3x. 3 minus 1 is what? Is 2. So you use power for 2. No, this is plus 0, right? 0 are so this is our final answer when differentiating this guy. Now that we already know how to differentiate, let's move on to the next section of this class. Let's look at product rule. Now let's look at product rule. We say number 1. Say if y equals to bracket x cubed minus 1 bracket what? 2x plus 1. So you should find dy over the x. If you look at this question, why is this called product rule? This question is called product rule because we have two functions. This function number 1, this function number 2, right? When two functions multiply together, we call it what? Product rule. Because there is a multiplication of what? Function. So that you know how to apply product rule, chain rule, and then in order rule. You need to know the particular question you are solving. But this question now is some of what? Product rule. Because we have one function here, this is another function. They are multiplied together. So since they are multiplied together, we call it what? Product rule. So now let's look at how to solve this question. Solution. Then the product rule formula is given as what? Product rule. The formula is given as what? We also find the y over the x. It is given as what? The y over the x. The formula is given as what? U dv all of what? The x plus d du all of what? The x. This is the formula of what? Product rule. This is the formula you are going to use when trying to solve this kind of question. Sometimes it can be a trigonometric function multiplied by an arithmetic function. Sometimes it can be an exponential function multiplied by a trigonometric function. So this is the formula you are going to use to solve it. Since it is form of our product, we apply this formula when finding the derivative of the function. So this is the formula for our product rule. Now let's look at how to apply this formula in solving this question. So now let's look at solution. You know that our y is what? bracket. This is what? Bracket 2x, this 2x plus 1, right? In fact, that now, our y equals to what? UB. I hope you understand. This u now is representing what? This first function. Now this y, this is the y, right? This u representing this first function. This b is representing what? The second function. So now, let's look at how to find the parameter. We already gotten what? U. And we have gotten what? B. Now let's look at how to find dv dx. For us to get dv dx now, dv dx. You know that dv dx, this is b, function b, derived with respect to what? X. That is what we mean by what? dv dx. So dv dx means that we are deriving function b with respect to what? X parameter in the function. So for us to derive this guy, you know that if we differentiate 2x, we're going to have, yeah, there's an invisible power 1 here, right? So this invisible power 1, when it comes down, we're going to have what? 1 times what? Still have multiplied with the entire thing, which is what? 2x, right? Then subtract, since there's an invisible power 1 here, this is this guy. Well, anything is power of 1, same than that thing, right? So there's an invisible power 1 here, so we bring down that power 1 to multiply the 10, which is 2x, right? Now we subtract 1 from that power. I hope you understand. So we're having 1 times 2x raised to the power of 1 minus 1, right? Then plus this plus here. Go ahead, deriving the function b with respect to x. When we also differentiate the constant, is 0, right? So this does not have x attached to it. So any number when we are differentiating a number in differential calculus is 0. So since we are differentiating this guy becomes 0. Because there is no x attached to this guy. That's why it becomes 0. So our dv, therefore our dv dx, because it goes to what? 1 times 2 is what? 2, right? Now, if you look at this guy, 1 minus 1 is what? 0. So 0, we have 2x raised to the power of 0, right? And based on law of indices, anything raised to the power of 0 is what? 1. So now this is for 0, right? So 2x raised to the power of 0 plus 0, right? Now what will happen? Our dv dx equals to what? 2x raised to the power of 0. No, that is raised to the power of 0 is what? 1. So we're going to have 2. 2 times 1 is what? 2, right? So we're going to have 2. So our derivative here is what? Is 2. Our dv dx here is what? 2. So we are getting the parameter of dv dx. Now let's find, we are getting this one, we are getting u, which is this guy. We are getting dv dx, which is this one we got differentiated. We are already getting what? B. B is what? 2x plus 1. But we are not getting dv dx. So for us to get du dx, we must differentiate the function what? U. Now, you know that our u is what? Our u is what? Our u equals to what? S2, right? Minus what? 1. So for us to get du dx, we are differentiating the function u with respect to what? X. Because x is the parameter in the function of what? U. So for us to differentiate the u dx, first thing I told us is that this power now will multiply the entire terms, which is what? 3 times what? X is the power of 3, right? Now, after that, you subtract 1 from that power. The power will be still there. The power will still be on top of the terms. Don't forget that. The power that you bring down to multiply the term will still be on top of that term. So don't forget that. Then minus what? 1. You subtract 1 from that power. Now, you have minus here. If you differentiate a constant, since it does not have value x attached to it, is what? 0, right? So therefore, our du dx equals to what? 3 times x is what? 3x, right? 3 power 3 minus 1 is what? 3 minus 1 is what? 2, right? So this is our du dx. Now we are getting the parameter Look at u is what? S cubed, right? U equals to what? S cubed minus what? 1. Our dv dx, we are getting it. Which is what? Our dv dx, we differentiate dv dx, what they are is 2. Our dv dx, what we have here is 2, right? Now, look at this line. Our v, we are getting v. What did it say that? It said that v is the second function, which is this line. 2x plus what? 1. So our v is what? Our v is what? 2x plus what? 1. Now look at our du dx. Our du dx, we are looking at du dx, this is what? 3x squared. So our du dx equals to what? 3x squared. Now we are getting all the parameters of the function product rule here. We are getting all this time. So what we are going to do now is to substitute those values into this formula so that we can be able to expand and get the final answer. So now let's start to substitute them. By this formula now, look at the formula. Our dy dx is equal to what? U. Are you seeing it? U. And the value of our u is what? Our u is what? S cubed minus 1. So we put here what? Bracket S cubed minus what? 1. Our dv dx, our dv dx is what? Our dv dx is what? 2. So we put what? 2. Because this is dv dx. Now after we have the cross, right? We put our cross here. After the what we have v, right? Our v is what? Our v is what? 2x plus 1. So we put our v 2x plus what? 1. After that, our du dx is what? Our du dx is what? 3x squared. So we put what? Bracket 3x squared. Why did I put it in bracket? I put it in bracket because if you look at, they are multiplying themselves. U is multiplying the v dx, and v is multiplying what? The u dx. That's why I put them what? In bracket. Now I will put them in bracket. Our major thing is to get the value of this u dx. So now let's start to expand them. Now our dy dx becomes equal to, look at it, 2 times s cubed is what? Going to give us what? 2s cubed, right? Minus, well, there's minus here. 2 times 1 is what? Is 2. Pay attention. This 2 will multiply everything in this bracket. This 2 will multiply everything in this bracket. Let's say I have this down. Then we come back to this side. We are done with this one. Plus, this plus here, this is the plus. Then this 3s cubed will multiply everything in this bracket too. So 3s cubed multiplied by this side. 3 times 2 is what? 6, right? If you look at this 3 attached with what? S cubed, right? And this 2 attached with what? X. And based on law of indices, when the two value is multiplied themselves and they are in the same base, we add the power together. You know that this is in base for x and this is what base x, right? There is an invisible power 1 here. So we're going to have what? Correct element of the base. So we're going to have what? X, right? Raised to the power of what? 1. And know that this s was the power of what? 2. So it's going to be what? Plus 2. Since they are multiplied themselves, let's try to take their power, add their power together. Now we are done with this one. Then 3 times 1 is what? This was here. 3 times 1 is what? 3, right? We know that this 3 was added with what? S squared. So we are going to have what? Therefore, our dy over dx equals to what we have up here. 2x what? Cube that we have here minus this 2 that we have here plus we have 6, right? X 1 plus 2 is what? 3, right? Then plus we have here what? 3x what? Square. Now let's just, what I want to do is to connect right ends, to add the right ends together. The one that have right ends, right? Look at this guy. Now our dy over the x become equal to what? You know that this guy have what? 2x cubed, right? And this guy is already become what? 6x cubed. So they are in the same what? Thing, right? So we add them together. We are going to have 2x cubed plus 6x what? Cubed. We put them together because they are in the same terms, x cubed. That's why we are adding them together first. Then plus 3x squared. We are arranging them in ascending order because power 3 before power 2. Now we have minus 2 here. Minus 2. So therefore our dy over the x equals to what? Now, since they are in the same base, 2 plus 6 is what? 8, right? Then 8 to the power of what? And x is the power of 3. This is 2s cubed plus 6s cubed is going to give us what? 8s cubed. Then plus, we have that 3x squared minus 2. And this is the final answer when solving this question using what? Product rule. So our divided by s give us what? 8s cubed plus 3s squared minus 2. So just do that step, one step after the other, and you are going to have the same correct answer. Please, if you have questions, you can drop it on the comment section. Thank you very much. Now let's move on. For another example of product rule. Number 2, we say if y equals to sine x bracket x squared, find the y over the x. If you look at this question, it's also from product rule because we have two functions multiply themselves. That's why we use what? Product rule. And for product rule, you know the formula we use when solving what? Product rule. So let's solve it together. Solution by product rule. By product rule, we also find the y over the x. By product rule, the y over the x is given by what? The y over the x. Always remember this formula. It's given by what? U dv dx plus d du dx. This is the formula of what? Product rule. Now, let's solve it together. You know that y is what? Y equals to what? Bracket sine x, right? Bracket x squared. That is the question they gave us. Now, this one says let u be what? This first function, which is what? Sine x, and b be the second function, which is what? S squared, right? Now at this point in time, from this first one, from u, right, equals to what? Sine x, right? From this first function, equals to sine x. Let's find our du now. Our du dx. We are deriving this first function with respect to x because the function is in terms of what? X, right? So let's derive this time. When you differentiate sine x, pay attention. When you differentiate sine x, I'm going to get what? Cos x. That's the method. When you differentiate sine x, I'm going to get what? Cos x. When you say you prove it, you're going to use first principle method to prove this. To get cos x, you're going to use first principle method. But if you want me to solve it in another video using first principle method, you can drop it in the comment section. Now let's present this diagram. Now from this guy, from v equals to what? X squared. From this side equals to x squared, we provide dv dx. Our dv dx is equal to what? By deriving this function v with respect to x. Because x is the term in the function v, that's why you say what? Dx. What we differentiate this guy, I told us that the power will come down and multiply the entire term, which is what? X This is power of 2, right? Like you have here. Now after that, you subtract 1 from the power. Because the power is still going to be on top of the variable, which is x. So you subtract 1 from the power. So our dv x will be what? 2 times x is what? 2x, right? Now if you look at this guy, 2 minus 1 is 1, right? And anything is power of 1, the same thing as what? That times. That's why I have 2x. So now I am putting the right parameter. I am putting all the parameters. This implies that we are getting what? Now our use what was sine x. These are u. Our b is what? What do you have for b? Our b is what? S square, right? S square. Now our du the s is what? Our du the x is equal to what? Du the s is what? Cos x, are you? Cos x. Now our dv dx is what? dv dx is equal to what? 2x. Now we are going to all the parameter that we want to get this divided x. Because what we are trying to prove is that we are trying to substitute value into this right hand side that will give us the value of dy over x. Since dy over x do not have a particular, do not know the particular value, so our middle way is to substitute all the terms that are gotten here, the value, into this right hand side. When we substitute into the right hand side, we say that dy over x is equal to those solutions that we got here. So now I look at that to solve it. Now substitute. Substitute the above value. Now let's substitute this value now into the function, the formula. Dy over the x. This is the formula of product. Dy over the x equals to what? U dv over what? The x, right? Plus v du over the x. Now let's substitute them into the function and check what we are going to have. From this formula now, our dy over the x equals to what? Our u is what? Our u is what? Look at it. Our u is what? Sine x, right? Sine x. Our dv dx is what? dv dx is what? 2x, right? Bracket 2x. We have what? There is plus here, right? Put the plus here. Our b is what? Our b is what? Our b is what? X squared. Our du dx is what? Our du dx is what? Cos x. Cos what? X. Cos x. Now let's try to expand it. Expand it. Let's expand. For us to expand this side, our dy over the x equals to what? Sin x times 2x is going to give us what? 2x sin x. You know what I put 2x first? Polynomial function before what? Trigonometric function, that is why. 2x first is in form of what? A polynomial. So you need to put it first before a trig function. That's why you have 2x sin x. You are done with this guy. Plus, don't make mistake here. Don't make mistake and put 2x squared. It's wrong. They are not in the same parameter. This is trig function. However, this one is a multiplied function or polynomial function. So don't multiply. Don't say 2x squared is wrong. Because they are not in the same what? Trig function. So this is what? 2x sin x when you multiply them plus x times this guy. X times plus x is what? Going to give us what? S squared cos x. And this is the final answer for this question that they gave us in product rule. I hope you are following. Okay, now let's look at the third solution of product rule before we move on to the next section. Let's look at the third Number 3, we are still on figure 2. If y equals to bracket square root of 3x plus 1 multiplied by sin x, find dy over dx. If you look at this function, this is still what product rule, because we have this function multiply what another function, so we are using what product rule. Now let's look at solution. Let's not go straight to the point. Solution by product rule. Always remember this formula. By product rule. See, they say you should find dy by the x, and dy by the x is given as what? Dy over the x given as what? U dv over the x plus v du over the x. You hold this first one, you differentiate this guy. That's what it means. Hold the first one, differentiate the second one, plus hold the second one, differentiate the first one. That's what you mean by this formula. That is short explanation of u dv dx plus v du dx. Hold the first one, which is u, differentiate the second one, which is dv dx, plus hold the second one, which is v, differentiate the first one, which is du dx. Because we are going to assume the first one as u, while the second one as what? V. So that is how this formula comes into what? Existence. Now that look at how to solve this guy. Say that this thing was to give us y equals to what? Bracket what? Y equals to what? Sorry. Y equals to what? Square root of 3x plus 1. 3x squared plus 1 multiplied by what? Sin x, right? Now at this point in time, you know that most of the differentiation is going to be very hard, right? So you need to first put in a good term for us to know to what? Differentiate. So we're going to have y equals to this guy is sitting as what? Bracket 3x plus 1. This is 1 over 2. Based on what? Law of indices. But 1 over 2, when you take it to the other side, it will equal square root of what? 3x plus 1. So this guy and this guy, they are the same thing. But this one will make it very easier for us to what? Be able to differentiate it. That is how I convert it to this form. Then multiply by this guy. Multiply by what? Sin x. Now at this point in time, we are done putting in the right parameter for us to be able to what? Differentiate this function. Now so let's assume that let u be this first function. This is what? Bracket 3x plus 1. This is power of 1 over 2, right? And v equals what? The second function is what? Sin what? X. I hope you're following. That's nice. At this point in time, say from this first function we assume from this first function which is u equals to what? 3x plus 1. This first one. This power of half from this guy, we are going to find du over the x. That means the derivative of what? The u function all over x equals to what? For us to differentiate this guy now, you know that this function here is going to what? Power what? Half, right? So for us to differentiate it now, we are going to use what they call chain rule to differentiate this guy. But I'm going to talk about chain rule after product rule. But let me just apply it here now so that when I talk about chain rule fully, you understand it. Now, for us to solve this guy, this 1 over 2, this is the power. As you are using the power rule, it's going to come down. This is 1 over 2. Multiply this entire function, which is what? Bracket 3x plus 1. Bracket what? Bracket plus 1 over 2 that you see here. This is the first step. Now what are we going to do is to subtract 1 from the power, right? Subtract 1 from the power. This is this power. But we are not done. We are not done Now we're going to differentiate t inside the bracket times differentiate the term inside the bracket, which is what? 3x plus 1. For us to differentiate this guy, if you differentiate 3x is what? 3 equals what? 3. Because there is an invisible power 1 here. When you multiply 3x, 3 equals what? 3x, right? This will be invisible power 1. Then 1 minus 1 is what? 0. So we're going to have 3x to the power of 0. And if this power of 0 is what? 1. So this x to the power of 0. So since it's this power of 0, it will be 1, right? 1 times 3 is what? It's 3. That's why I have this 3. Then if you differentiate the constant, is 0. So that's why we have this one here. So our du dx is given on this guy. Imply that we are not done yet. Our du dx, our du over dx equals to what? Half, right? Multiply this guy. You are having half multiplied by what? Half multiplied by what? 3x plus 1. 3x plus 1. Look at this guy. 1 over 2 minus 1. 1 over 2 minus 1. Let me put it in form of fraction. All over 1, right? Take the LCM. 2 over to 2 is what? 1. 1 times this guy. 1 is what? 1. Minus 2 over 1 over to 2 is what? 2 times, right? 2 times the upper 1. Going to equals what? 2. So 2 minus 1. 1 minus 2 is what? Minus 1. All over 2. So what I'm going to have here now is going to be what? Minus 1 all over 2. Times the 3 we have here. And the 3 we have here. Now at this point in time, we're going to have these 3. We multiply this guy. So we have our du over dx equals to what? If you take this down up here, we're going to have 3 multiplied this guy equals what? This is going to give us 3 all over 2, right? Now if you look at this guy, it's going to give us what? Bracket. This is minus. It's going to give us what? 1 all over. Here you have what? Bracket 3x plus 1, right? This one half will come down, right? This is what you have here now. So our du dx equals to what? 3 times 1 is what? 3, right? All over. You see I have 2 at the down, right? If you look at this down side here, this is the same thing as what? 1 over 2, right? This is the same thing as square root. The same thing as square root of this entire function in the bracket, which is what? Square root of 3x plus 1. So this is what we are having. This is our du over dx. 3 bracket 3 all over what? 2 bracket what? Square root of 3x plus 1. This is our du over dx. Now let's look for here, the second function, which is d. From the second function, which is d equals to what? D equals to what? Sin x. Our dv over dx. Our dv over dx is equal to what? If we differentiate sin x, we're going to go to what? Cos x. Cos x. Now we are getting all the parameters. We are getting what? Our u. We are getting our b. We are getting our du dx. And we are getting our dv dx. So let's substitute into the formula. And tell you what we are going to have. Now, from the formula here, you know that our dy over dx equals to what? U, right? Our u is what? Check from here. Our u is what? You say our u is what? This first function. And the first function, what is what we have? We have a bracket. We have bracket what? 3x plus 1. That was our u. This is what for half. That was our u. Then our dv dx is what? Our dv dx is what? Cos x. Bracket what? Cos x plus our b cos, you can just stop at this point. If you can't expand it, there is no problem. You can stop at this point. They are the same thing. Cos multiply this guy. You're going to have what? 3 cos x plus if you multiply over here, you're going to what? Cos, right? This is the power of this one, half. But I can say let's stop here. Let's stop here. Let's stop here. If you stop here, there's something bad, the same thing as the answer. So that is the final answer. Because sometimes let's just look at another question. But if you want to expand it, there is no problem. You can expand it. You can just say cos multiplied by 3x give you 3x cos x. Cos multiplied by 1 will give us cos x. Now, in bracket this power of 1 all over 2. Then cross. You multiply this guy with this guy. Will give you what? 3 sin x all over this guy. That is it. That's how to solve it. But if you want me to just show you very things that I don't know how to do, in case you want to expand it, divide over the x. Because what? Cos multiplied by this is what? 3x cos x. Cos multiplied by this guy will give us what? Cos x. This power of half, right? Plus sin x multiplied by 3 will give us what? 3 sin x all over what do you have here? 2 bracket square root of what? 3x plus 1, and this is the what? Final answer. If you stop at this point, it's not bad. If you stop at this point, it's also not bad. This is the final answer when expanding the solution that we have above. I'm telling you, chain rule. Okay, let's go out to solve this guy. Chain rule is given by dy over the x equals to what? Du over the x times dy over du. We use chain rule when a function is raised to power. So let's look at example. Example 1. Say if y equals to bracket 3x raised to power of 2 plus what? 2x raised to power of 3. Find dy over the x. Now if you look at this question, you know that this is a function, right? And the function is raised to power 3. Since this function is raised to power 3, and the power, we call it for chain rule. Chain rule is in the form of what? When a function is raised to power, let's only apply what? Chain rule. Know how to apply all these things because it's very important when solving calculus. You know when a function multiplies, we use what we call product rule. When a function is raised to power, it can be power 100, it can be another function. We use what we call chain rule. When a function is divided by this order, we use what we call quotient rule. We are going to get to that point using what quotient rule method. Now you can solve this time using chain rule formula. Solution. You know that y equals to what? You say y equals to what? Bracket 3x squared plus 2x this is power of 3, right? First to find dy over the x, change to find dy over the x. And dy over the x is change u and du over the x times dv over the x. So now, let's start to solve this line. He said let u be the entire function in the bracket. This is this line. Let it be this line. 3x what? Square, right? Plus what? 2x Since this guy is what? U. You put U in place of this guy. Then raise to the power of 3. I hope you understand. I hope you are following. Because since you are adding that this everything in this bracket is U. You now use U to represent everything in this bracket. But note that there was 3 on top of those 10. That's why you put this 3 here. I hope you are following. Okay, that's good. Now, let's find our dy du. Let's derive this guy now. Our dy, which is the function. We're deriving the function y. That's what we mean by dy. Our dy over du. U is the terms in the function y. That's what we mean by du. dy du. U now is like a parameter in the function of y equals to what? When we use power when differentiating, I told us that the power, which is 3, we multiply the entire function. This power 3 will come down, which is this guy. Multiply this entire term here, which is what? U, right? This is power of 3. The power 3 is still on top of the U. Don't forget that. We bring down the power 3 to multiply the entire function. But note that the power 3 is still on top of what? The U. Now, since the power 3 is still on top of the U, based on the formula, we subtract 1 from the power. We subtract 1 from the power. Now, at this point in time, our dy over the U is going to what? 3 times U is what? 3U, right? Now, 3 minus 1 is what? 2. So we are gotten our parameter what? Dy du. We are gotten what is what? 3U is power of 2. Now let's find our parameter du dx. Now note that on this guy, now note that we say that what? We say that u equals to what? We say that u equals to what? Every term in this bracket, like the function in the bracket, which is what? 3x squared plus what? 2x, right? Now let's derive u with respect to x. So the derivative of the function u with respect to x, which is this parameter in this function, is going to equal to what? Remember we are differentiating terms by terms, right? So this power 2 will come down and multiply the entire function, which is what? 3x what? Square, right? Then you subtract 1 from that power to bring down. Subtract 1 from the power here. I hope you are following. That's nice. Plus, this is 2s, right? But you know that this 2s is based on an invisible power 1, based on law of indices, right? So we're going to bring this invisible power 1 here to multiply the entire function of what? 2x. There's still an invisible power 1 on top of it, right? Now, based on the power rule method, we are going to subtract 1 from the power. I hope you are following. Okay, that's nice. Now, imply that our du over the x equals to what? 2 times 3 is what? 6, right? This is x, abi? We put our x. 2 minus 1 is what? Is what? 1, right? But anything is power 1, the same thing as that terms, right? That's why I did it at this time. Go to this side. 1 times 2 is what? This is plus, so this is the plus. 1 times 2 is what? 2, right? Now, you know that you have x here, right? 1 minus 1 is what? 0, right? Hope you understand. I hope you understand. Let me explain it again. Our du dx equals to what? 2 times 3. Going to give us this 6. And we have x here. X to the power of 2 minus 1. 2 minus 1 is what? Is what? 1, right? I hope you understand. Let me put this one so I can understand. Plus 1 times 2 is what? 2, right? We still have x, which is this x is here. Now, on top of the x, we have 1 minus 1. 1 minus 1 is going to give us what? 0, right? So, therefore, our du over the x is equal to what? 6x. Because it is power of x. If 1 is raised to power 1, if x is raised to power 1, the same thing as that word, x. Any value that is raised to power of 1 is still going to give us what? That value, or that what? Variable. So, we are going to have what? 6x plus, we have 2 here, right? Now, if you look at this guy, x is raised to power of what? 0. And by the law of indices, anything raised 1. So we have what? This end becomes what? 1. Therefore, our du, the x, equals to what? 6x plus what? 2 times 1 is what? 2. Now we are getting our parameters. We are getting our parameters. Now let's substitute them into the what? Formula. Let's substitute them into the formula. Let's substitute them into the formula. Okay, let's substitute them into the formula. Note that. Note. He said our u is what? Our u equals to what? 3x squared, right? Plus 2x. That's our u, our u. Then we know that this was our u for this function. But when we differentiate this u, what do we have? When differentiating the u, when we differentiate the u with respect to x, we have what? We have the u x equals to what? 6x plus 2. Our du dx give us what? 6x plus 2 that we have here. That we have at this point. Now, we are talking about du over dx. Now, our dy du, what do we have for dy du? Our dy du give us what? Our dy du give us what? 3u squared. 3u squared. Now let's substitute it into the formula and get the final answer of our dy dx. Now from the formula, our dy over the x equals to what? Our dy over the x by changing formula is equal to du over the x times dy over the du, right? So note, our du dx is what? Our du dx is what? 6x plus 2. 6x plus 2, right? Times, we put the times. Our dy du is what? Dy du we have what? 3u, this is power of 2, right? Which is what? 3u, this is power of 2, right? This is what we have now. Now, but note that our u is what? Our u is what? 3x what? Square, right? Plus 2x. Now we're substituting u. Substitute u now in place of this guy. So I'm going to have dy over the x equals to what? Bracket 6x plus what? 2, right? Times, this is 3, right? 3. Our u is what? Note our u is what? 3x squared plus 2x. You use, substitute this value in place of what? U. You're going to give us what? 3x squared plus 2x, right? But note that u was going to power of 2. Power 2. So our final answer is what? We can leave it in this, we can leave it at this point, or you can expand it. You can leave it at this point, or you can expand it. So our final answer is dy over the x equals to what? Let me just bring out this thing. Then bracket what? 6x plus 2 that we have here. Bracket this guy. 3x squared plus 2x. This is power of 2. And this is the final answer. And this is the final answer. This has to solve chain rule. And this is the final answer. Let's move on to the next question. Okay, number 2. Say if y equals to bracket sin x is to the power of 2. Find dy over dx. If you look at the question they gave us, you know that this is form of what? Chain rule. Because a function is raised to what? Power. So we apply what? Chain rule what? Method. So solution by chain rule. By chain rule. By chain rule, you know that our dy over the x equals to what? Can start by dy over the u is the same thing. Dy over the u times the u over the x. You can start by the u over the x times dy over the u, or you can start by the dy over the u times the u over the x. Simply and multiply. The place of position does not matter. So now let's move on. You know that our y equals to what? This is what it is. Y equals to what? Bracket what? Sine x, right? This is power of 2, right? Now let's assume let u be the function in the bracket, or all the terms in the bracket. This is what? Sine x, right? Now, since u because everything in the bracket implies that our y equals to what? U raised to the power of 2. Because I said that every function, everything in the bracket is becoming our u, right? So this guy is representing this sine x. The u is representing the sine x. So I have our y equals to u raised to the power of 2, right? Now let's find our divide the u. Now let's differentiate y, which is the function, with respect to what the u parameter in the function. So we are going to have divide the u equals to what? If you differentiate this guy, this power 2 will multiply the entire thing here, which is u, this is power of 2. This 2 now will come down and multiply this entire thing, right? Which is this guy. After you have done that, you still subtract 1 from that power 2 that is on top of the u. So that's how we differentiate using what? Power law. Now after you have done that, you know that our dy over the u equals to what? 2 times u is what? 2u, right? Then 2 minus 1 is what? Is 1. There is an invisible 1 here. There's going to be 1 here. I know that anything that's the power of 1 based on law of indices is the same thing as that thing. Or that value. That's why you leave it as what? 2 raised to the power of what? That's why you leave it as what? 2u. So this is the final thing. 2u. Now we are getting the parameter of what? Dy du. Now let's find the parameter of what? Du dx. Let's find the parameter of what? Du dx. Now, you know that for this guy, you know that you said that u is what? Equals to sine x, right? For us to differentiate the function du over the x. Du over the x is telling us that we should differentiate the function u with respect to x, and x is the parameter in the function of what? U. That's why we look at what? The u over the x, differentiating u function with the parameter of x in the function. So the u over the x, you know this is our u, right? We are differentiating this u with respect to x in the u function. So we are going to have, if you differentiate sine x, you are going to have what? Cos x. Cos x. Oh, look at this one. You are going to have cos x if you differentiate what? Sine x. If you differentiate cos x, you are going to have what? Minus sine x. But let's move over and look at that thing now. So the u dx will give us what? Cos x. Now we are going to call the parameter. We know that our u equals to what? Sine x, right? And we know that our dy du equals to what? 2u, right? 2u, sorry. 2u. And we also know that our du dx equals to what? Equals to what? Cos x, right? We are cutting all the parameters to substitute into the what? Formula. Now, by changing the formula, we know that our dy over the x equals to what? Dy over the u times du me give you a secret. You know that this du can cancel this du, right? And we have dy over the x. And dy over the x here is the same thing as what? Dy over the x here. That's how you are going to know that you have the answer correctly. So this is the formula for chain rule. Now our dy over the x equals to what? Our dy du is what? Dy du. Sorry, this is du. This is du. Dy du is what? 2u, right? 2u times our du dx is what? Du dx is what? Cos x. Are you seeing it? Now, we're going to have what? You know that our u is what? You know that our u was what? Sin x. That means the value we assume that let the value is the bracket in what? U. So we are going to replace that value back. This is what? Which is what? Sin x. So substitute sin x now in place of u. So our dy over the x equals to what? 2. This is u, right? This is u. But since our u was what? Sin x, I'm going to put sin x there. Sin x. Then multiply by what? Our what? Cos x. So therefore our dy over the x is equal to what? 2 sin x and cos x will equal to sin x cos x. And this is the final answer. This has to solve using what? Chain rule. And I also want you to practice it by yourself and see how I did it. Thank you very much. Okay. When we talk about quotient rule, we use quotient rule when a function is being divided by another function. When a function is in form of a fraction, that's when we use quotient rule. We use quotient rule if y is in form of a fraction. Like this is a function, all of another function. That's when we apply what? Quotient rule. Now, for example, quotient rule formula is given by what? The formula is given by the y over the x equals to what? V du all of what? The x minus u dv all of what? The x then all over v squared. This is the formula of quotient rule. We use quotient rule when a function is in form of what? Fraction. So this is the formula for what? Quotient rule. Now let's solve one example. Example 1. We say if y equals to what? Sin x all over what? Cos x. Find dy over dx. I'm using trick now, trick function to give us how to solve what? Quotient rule. Now let's have to solve this time. Solution. We are going to use quotient rule because this question is in form of what? Fraction. That's why I apply the quotient rule. And the formula is given as what? Dy dx equals to what? V du over dx minus u dv over dx all of v squared. What does it mean? You hold the first in that part, bottom, hold the bottom, differentiate the top. That's what you mean minus. You hold the top, differentiate the bottom, then all of the bottom square. That's what you mean. That's how you call it. That is for quotient rule. So let's move on solving this guy. Now we know that y equals to sin x, right? All of cos x, right? This is the question differentiate sin x, we have what? Cos x, right? Now we're done with this first function. Now also from the second function, we're going to differentiate the second function, which is what? V equals to what? Cos x. For us to differentiate the function dv dx, differentiating the function v with respect to x, we're going to have what? If you differentiate cos x, what are you going to have? Minus sin what? X. Just note that. If you differentiate sin x, you're going to have cos x. If you differentiate cos x, you're going to have minus sin x. Now we are putting all the parameter. Now, we know that our u is what? We know that our u is what? Our u is what? Sin x can be. You know that our v is what? Our v is what? Cos x can be. Which is this guy. You know that our du dx is what? Du over dx. Our du over dx is what? Our du over dx is what? Cos x and v. And we also know that our dv dx is what? Our dv over dx. Our dv over dx is what? Minus sin x and v. Now let's substitute this guy into the word formula. That's what I'm going to do now. Let's substitute this parameter. This parameter u equals to sin x, v equals to cos x, du dx equals to what? Cos x, and dv dx equals to what? Minus sin x. Let's substitute them into the word, the formula of what? Quotient u. What is the only way for us to break what? Our dy over dx. Alright. For the formula of quotient, what do we have? Our dy over dx equals to what? You know that I have what? This is b and b. B du over dx minus u dv over dx. All about b square, right? Now I'm going to substitute this guy into the formula. Then you have to substitute them now. Our dy over dx equals to what? Our b is what? Our b is what? Cos x and v. Cos x. Our du dx is what? Du dx is what? Our du dx is what? Our du dx. Look at what we have. What we have for du dx? Cos x also. Our du dx is what? Cos x. Then minus. Our u is what? Sin x. Our u is sin x. Our dv dx is what? Dv dx is what? Minus sin x. Minus sin x and v. I don't with the denominator. All over. Because it's all over here, right? Our b square is what? Our b is what? Our b is what? Our b is what? Cos x and v. B is what? Cos x. But you know that the b is equal to what? Power 2. You put the power 2 here. Hope you are following. Okay, that's nice. Now let's look at our dy over dx equals to what? Our dy over dx equals to what? Cos x times cos x will be equal to what? Cos square what? X. Cos x times cos x will be equal to cos square x. Look at this guy. Minus times minus is what? Is plus, right? I hope you are following. Minus times minus is plus. Sin x times sin x will be equal to what? Sin square what? X, right? All over what? Look at what is happening here now. All over what? Cos this cos x square, right? Times this will be equal to what? Cos square what? X, right? Now at this point in time, what are we going to do? You need to understand that cos square x plus what? Sin 1 by trigonometric identity. Now we have cos square x as the numerator, so we will have cos square x plus sin square x equals to 1 all of cos square x, which is at the numerator here. Therefore, our dy over the x equals to what? Now if you look at this guy, 1 over cos square x is a trigonometric identity. So 1 over cos square x in Greek is what? Sec what? Square x. So this is the final answer. 1 over cos square x in trigonometric identity is what? Sec square x. So the final answer is what? Sec square x. When deriving the function sin x all over cos x. So thank you very much. I really appreciate the fact that you are here, and this is Simplified House 10 tutorial with Barade Mbaradu Maths Academy. If you are not subscribed to the channel, I would like you to subscribe to this channel, like this video, share with your colleagues and those in need of mathematics. And God bless you. I'll see you in the next series of our tutorial. If you know that you have any question, you can drop it on the comment section. If you also know that you have any topic that is bothering you, you can also drop the topic on the comment section so that I can be able to make a video on it. God bless you. I'm very happy that you're here. Thank you. I really appreciate your presence. Thank you.